Good morning, students. So today we are going to see how to find solution for undamped free vibration for single degree of freedom system. Okay. So in the last video we have seen how to formulate the equation for single degree of freedom system. So we have already formulated an equation for single degree of freedom system, which is mx double dot plus kx equal to 0. Okay. Hope you remember. So we have drawn the mathematical modeling. So mathematical modeling for a single degree of freedom system is having a stiffness K. So inertia force will be there. We draw the free body diagram. So I'll be having mx double dot and spring constant, spring force, stiffness into displacement. Okay, with this, after resolving, we'll be getting this equation of motion. Okay, so now we are going to solve this differential equation in order to get the solution for undamped free vibration. Okay, first to solve this differential equation that is of second order, we have to find the write the auxiliary equation. Okay, hope you remember your school mathematics. So auxiliary equation, so we'll be writing this as d square, okay, plus, so d square, so x double dot is can be written as d square, and this m will can divide throughout by m, so this m will become 1, and this will be k by m into x equal to 0. So this we can write it as d square plus omega square of x. So this we can write it as of x equal to 0. Okay. So auxiliary equation we can solve it like this: omega square equal to 0. This is the exact auxiliary equation. So we want d can be written as plus or minus I omega. Okay. Here omega I am going to take it as natural frequency. Okay. Natural. So that's why putting suffix n. Okay. So for this auxiliary equation, so I can write the solution in the form of, so hope you remember, just put a note. Okay. Suppose if you are getting this auxiliary equation in the form of alpha plus or minus I beta, okay, the solution we can write it like x of t equal to e power alpha x, okay, of a cos beta x plus b sine beta x. Okay, so here alpha is 0. Okay, there is no value here, so it is 0, and beta is omega n. Okay, now I am going to write this as the solution. So therefore the solution will be x of t equal to, so e power 0, alpha is 0, anything power 0 will be, e power 0 will be 1. Okay, so we'll be getting finally a cos omega n. So here x means here we have to consider in terms of t, because it is a dynamic analysis with respect to time. Okay, plus b sine omega n t. Okay, let this be equation number 1. So here we have to find the a and b constant, and we have to substitute here to get the final solution for this undamped free vibration. Okay, for which we need some initial condition in order to get the constants. So what are those initial conditions means? Okay, at time 0, x will be x naught. Okay, displacement will be initial displacement, and velocity will be initial velocity. Okay, now I'm going to substitute these two initial conditions in this equation. I'll be finding A and B, then I'll be substituting in this equation. Okay, so first I'm going to substitute this first term. This is x. Okay, if I am substituting, okay, substitute initial condition 1 in 1. So what I will get? So x naught, okay, which is equal to cos 0. Okay, cos 0 will be 1 plus sin 0 will be 0. So I'll be getting A is equal to x naught. Okay, A is equal to x naught. And it's same thing. I'm going to substitute initial condition 2 in equation 1. So if I, sorry, so I need velocity for which I have to differentiate this once. Okay, so if we differentiate 1, cos omega nt will be minus sine, right? And we have to differentiate this separately, you'll get additionally omega n I will get. So if I differentiate, I'll get minus sine omega nt, and additionally I'll be getting omega n if I differentiate this alone. Then sine I'll be getting cos, differentiation of sine is cos, and additionally I'll be getting omega n. So let this be equation number 2. I'm going to substitute in equation number 2. Okay, in 2. So if I substitute here, what I will get? X dot is equal to x naught. So I'll be getting x naught dot is equal to, so if I substitute t equal to 0, obviously the entire term will become 0. Okay, plus, so cos 0 will be 1. Okay, b into, I'll be having b omega n. Okay, so what I need? I need b equal to x naught dot by omega n, right? So this is b. So I got a and b, substitute in equation number 1, and that gives you the solution for this equation. X equal to, so a is x naught. I'm going to substitute here x naught cos omega nt plus b value x naught dot, okay, by omega n. So substitute here, so x naught dot by omega n sine omega t. Okay, so and this is the final solution for undamped free vibration of a single degree of freedom system. Okay, I hope you have understood the concept well. Okay, just a quick recap. So this is the equation of motion for single degree of freedom system, and to find the solution, we have to write the auxiliary equation. So d square x double dot can be written as d square plus m should come down, k by m equal to 0, and k by n can be written as omega n square. So auxiliary equation, I have to put this term equal to 0. If I bring here, you will get minus omega n square. If I take root, I will get root of minus 1, which is I, complementary function, I omega n. So this is of the form alpha plus I beta. So 0 plus or minus I beta. So alpha is 0 and beta is omega n. So this is the general solution. X of t is equal to e power alpha x. Okay, this is alpha, e power alpha x into a cos beta x plus b sin beta x. So I am going to write the solution here in this form. So e power 0, alpha is 0 here, e power 0 will be 1, a cos omega nt plus b sin omega nt, and I have to differentiate once to get the velocity x naught dot. So corresponding differentiation is done, and the initial conditions, okay, at t equal to 0, x will be x naught, at t equal to 0, x dot equal to initial velocity x naught dot. So substitute the condition, initial condition 1 in equation number 1. Okay, so if I substitute, cos 0 will be 1 plus b sin 0 will be 0, I will get a equal to x naught, and a second condition in equation number 2, and I'll be getting this one. Okay, this is the corresponding solution, right? Thank you so much. So give your comments in the comment section to improve. Okay, thank you.